Hello, this is Along, and I'm here to show Netdiscover. So I wanted to just introduce a quick Cali tool that you can use for reviewing MAC addresses and mapping them to IP addresses, essentially. Um, just to quickly show you, it's a pretty simple tool, and so because of that, I'll be just quickly going over the man page or the manual. Not going to run you through the whole list of items, but I do want to put the emphasis on the title of this, an active passive ARP reconnaissance tool. So basically this is a active scanning or passively listening tool that you can use that uses ARP or address resolution protocol, which essentially maps IP addresses to MAC addresses so that devices know how to get to a certain device. Now, I will tell you that you will want to look at through the first few parameters here. The most important one probably being the device, because if you do have multiple network interfaces, it's going to choose the first available, which you may not want. So, with that being said, let's just look into it. I will find out what my Ethernet is, and we can type IP adder, which is short for IP address. Again, you could also just type IP address or IPA. In any case, this is going to be the network that we're going to be scanning on. So with it being a /24, that means, and I'll just type it down here, that it will be scanning from this IP all the way to this IP. This is the range that we're scanning. Now, keep in mind that ARP is used for layer 2. That's how devices find each other so that they can go to the next level of using IP addresses. They look at MAC addresses and then they map them to the IPs. So when you run this tool, you will have to be on the same network that you're scanning from, because there is a thing called a broadcast domain, and that doesn't go past routes. So if you wanted to try to go to 192.168, let's say .50, this is not going to work unless it somehow is on the same, network, right? Which it's not. So with that being said, let's run into this tool here, and let's just say sudo netdiscover. And then in sudo, by the way, is to elevate privileges, because this tool will be using your network adapter to run, privileged items so that it can scan the network, right? So we will put our interface, and we're going to put that ETH0, that network interface we have, and we'll just scan real quick, right? So this is going to go by very, very quickly, right? And matter of fact, just so y'all can see, I will go ahead and run Wireshark, which is a packet sniffing tool, so that you guys can see what is going on here. And there you go. That's what's going on here. And matter of fact, you can see that it is running through a bunch of addresses, and it's even going past the network, right? So if you don't define a range, it's going to presume that you want to look at the entire class C, or basically this whole subnet. It's basically looking through from here all the way to here, which is like 6 million addresses. We don't want that, and it's also going to blow up the network. It's not going to actually blow up the network, but it's going to send a lot of traffic. If you are doing a pen test or something like that, that's a no-go. You do not want to do this. It's going to be setting off alarms or causing just a little disruption to the network. I don't know if it would necessarily break it, but it is a lot of traffic. So that's where I will go and do a -H, right? So I specify that you want to choose your device. We also want to ideally set a range, right? So that's where we do this. We do a -R for range, and we specify our network in our network only. So there's that. Now there's a second part in that was a lot of traffic. Even on a /24, that's 255 addresses, and it sends 2 packets for every address. Now let's look at that one more time just to show you guys what that looks like. That's a lot, right? I'm going to actually stop this, and we're going to run a new scan here. I have not started it, but we're going to go ahead and rerun it one more time. And now it's only going to do the /24, and let's go and check out what that looks like. So it's still a lot of packets, and you'll see on the timestamps that it's sending this about every 10 milliseconds, essentially. So that's pretty quick. That's still a lot of traffic very quickly. Now, I do want to explain what's going on here before we move further. At the very beginning, and again, this is a packet sniffing tool so that we can basically visualize what is happening here and what's going on in the background when it's actively scanning. So when it's actively scanning, it's going to send a gratuitous ARP. What that essentially means is that our Kali Linux VM is going to be telling everyone else on the network that, hey, I'm the router. The Linux machine is looking at its gateway and it's saying, like, okay, here's my gateway. This is the router. This is my path out to get to the internet. A lot of devices are probably going to look at that. And even IT administrators might know that this kind of scanning might be a thing. And they might just say, hey, only allow ARP traffic to come from the gateway. Well, if you are telling all the devices that you're the gateway anyway, well, there you go. You got past that hurdle. So basically, we're telling all the devices first, hey, I'm the router, just letting y'all know. And then after it does that, it's going to be asking every IP on that subnet twice, just in case there's any packet drops on the first one. It's going to be sending it basically every milliseconds, right? Or every 10 milliseconds. And what's going to happen, and you may have already saw this as I was scrolling down right here, devices respond. So when a device is asking, hey, who has .1.108? I need to know your MAC address so that I know where I'm going. And my Philips Light basically saying that, yeah, I have that address and here's my MAC address if you ever need to go to me. And it keeps on going and it keeps on getting responses back. And Wireshark is good in that it knows how to resolve MAC addresses. You can simply just go to name resolution and resolve physical addresses. How it does that is the 7C, 10, C9. That first half of a MAC address is always the OUI, or the organizational unique identifier. that basically identifies the company that makes the network adapter. So still, this is too much. I don't like this. This is going way too quick. So let's go back to our machine real quick. And it finished, which is great, but it's still, the active scan has finished. It's still listening, and you can see that it increments, especially on the actual router itself, pretty frequently. This count is basically just telling you how many replies it's getting back. Some of this stuff happens without the need for this device to even scan. Matter of fact, if we go again back to -H, we have a passive mode. We don't have to actively tell everyone, hey, what's your address? They'll just do them normally, because ARP addresses, and you know what? Yeah, let's run this real quick. I was going to go through the seconds part. Actually, yeah. No. Let's go through the seconds part. So, like I said, it sends a lot of traffic. So we might want to do this maybe every second or every 10 seconds. So this -S, we can say, and this goes by the metric system, right? So, millisecond is 1/1000th of a second. So we will say 1000. We'll scan that. And while I go back to my Wireshark capture and let's just redo it again, you'll see that instead of doing it all at once, it just goes ahead and does that, right? So it goes throughout all the addresses and whatnot. Fantastic. Yeah. So that's cool. So now we're not blowing up the network right away. And now, if we instead maybe just want to listen, let's just put a -P. This might be the best way, honestly, because devices often are going to ask where they need to go, right? They're going to ask, hey, I need to go to this IP address and I don't know where it is. Please tell me where you are. So we'll do a -P here. Now, it's not going to be instant, as you'll see. This is actually, and you'll see it up on top, passive, right? So this is actually just waiting for devices to respond back. Let's go back to our Wireshark capture here, and we'll continue without saving. And I'm just going to go and say, just look for ARP, right? So you're going to see a bunch of ARP requests. And this is actually, this 1C is from my Ubiquity router, right? That's going to be doing most of your ARP requests because that's the router, and the router needs to know where to tell everyone else to go, basically. Or rather, the switch. It could also be a switch. I don't really have a switch, so that's going to be our device there. But yeah, so you can see that these devices don't even need the Kali box. They're just doing their own, basically doing their own thing. They're just sending it back and forth, talking to other different gateways and stuff. Matter of fact, if I, let's say I'm going to try this out. I don't know if it's going to work, but if I go ahead, this is my personal machine, and just to show you, and let's add a -C to give it some color. This 166, that is my IP address, right? So let me ping something that probably doesn't exist on my network. I'll just do, let's do 253, right? And let's pay attention to this side here. I'm going to ping it. And you see it right here. Asus, so that's my machine. I'm asking, hey, who has this? Who has this? Who has this? Does anyone have this? And it keeps asking because I'm constantly pinging. And I'm not getting any responses. And that's what you're seeing here. I'm not getting any responses. No one's telling me where this is because it doesn't exist. So that's kind of how this is working in a nutshell. So we are listening to that, and if we go back to our Kali box, you might actually see a lot of counts because of my pings. So all this to say, the passive is just listening in on other devices, attempting and or successfully as well, or failing like I did with my pings, trying to figure out where an IP address is, and in doing so, it's giving its own MAC address and IP. Now we were focusing on destination stuff, but remember that this is coming from a source as well. If we're listening in, we're actually looking at the source MAC address, and that source MAC address is basically telling us down here, hey, here is my IP address, here is my MAC address. You just mapped a potential, target, right? And obviously a threat actor, if they're, this tool says it, but like you can easily map out the MAC address to, whatever tool, like, I'll figure this out. Yeah, let's do this one, right? Sorry for the very small fonts here, by the way. But we can do an OUI lookup. And again, we're picking the first half. This is essentially what Wireshark uses. And you can see this is the manufacturer. Boom. There we go. So the tool does it for you. But if you don't have that ability, or, you need to figure it out your own, you can also just look it up online, and it's easy as that. Some of them are going to be unknown. I know iPhones in particular, they rotate and use unique randomized MAC addresses, so you might not even ever know what an iPhone might be on because it's rotating its MAC address or is on a randomized MAC address, right? So in any case, that is kind of this tool in a nutshell. It's very simple to use, but the concept is important, right? If you don't specify -P, it's going to be actively scanning, and you want to make sure that you're not hammering the network. So make sure you specify a range so that you're only scanning the targets that you want. And then also maybe put a little bit of delay so that you're not sending out thousands of ARP requests every second, or, every few seconds. That is a recipe for disaster, especially if you're doing this on a client's network, right? Or, if you're pen testing. But again, I would lean towards maybe doing a -P first. And if you want to go a little bit more, just make sure you tag on the seconds, scan, and then just, bring this out. And again, you can do you can export this to a file. If I recall, you can, actually, no, you cannot, but you can use other tools to basically put the output to a file. So that's easy enough. But anyways, I hope this was great, and thanks for watching.